Hey guys, so today we're going to solve an example problem that you might find in a college algebra textbook. So here's what it looks like. We have a polynomial of the fourth degree, x to the fourth minus 8x squared plus 3. And there's a couple parts. So in the first part we have to draw the graph, we have to find the number of x-intercepts, the number of turning points or inflection points, and the behavior of the function as x goes to left and right. So as x goes to the positive and negative infinity. And in the second part we have to approximate the largest x-intercept. So let's get started. We can rewrite the function we have right here. And as you'll see, it's a polynomial to the fourth degree, which we don't really know how to solve. But we do know how to solve a polynomial to the second degree, a quadratic equation. And if you haven't checked out our video on that yet, please do that first, so this will make sense. So what we can do here is we can substitute x squared for t. And then if we rewrite it, it'll be y equals t squared, right? Because x to the fourth, so then we need to take t to the second power to get x to the fourth, minus 8t plus 3. And now this is a simple quadratic equation that we know the solution to. And the solutions are the two roots, t1 and 2, minus b, so 8, plus or minus the square root of b squared, 64, minus 4ac. So 4 times 1 times 3 is 12. And this is all over 2a, so 2, because a is equal to 1. So let's simplify this. It's 8 plus or minus the square root of 52 divided by 2. Now, if you notice, 52 can be rewritten as 4 times 13. And this is all divided by 2. And then we can take the 4 out of the square root. So it'll be 8 plus or minus 2 times square root of 13 divided by 2, right? Because 2 is the square root of 4, obviously. And then if we divide everything by 2, we'll have our two solutions of t, which is 4 plus or minus the square root of 13. But we're not done yet, because so here we said that x squared is equal to t. So then we still need to take the square root of this to get our 4x's. So let's do that. x1 will be the square root of 4 plus the square root of 13. x2 will be the square root of 4 minus square root of 13. x3 will be minus square root of 4 plus 13. And x4 will be minus square root of 4 minus square root of 13. So we have 4 really confusing roots here. Now, if you remember, in the second part of the question, we have to approximate the largest part to 2 decimal places. And we'll do that later. Right now, we'll just cheat and plug these into a calculator and find out the values. So the first one, the largest obviously, is approximately equal to 2.76. This one is equal to minus 2.76. Then this one is equal to 0.63. And this one is equal to minus 0.63. So these are the 4 roots that we can then use to graph the plot. Okay, but now we still need to find the number of turning points. So how can we do that? Well, the first thing we need to do is to take the derivative. Y equals x to the fourth minus 8x squared plus 3. And let's find the derivative. So the derivative is 4x cubed minus 8x, minus 16x, I'm sorry, because we multiplied by 2, 16x. And we can factor out 4x and rewrite it like this. Does that make sense? Because 4 times 4x is 16x, and x squared times 4x is 4x cubed. And then this can be rewritten as 4x, x plus 2, x minus 2. Now, because we want to find the inflection points, we have to set this equal to 0, because that's when the derivative, or the tangent, is flat. So it has a slope of 0. So when is this true? Obviously, it's true when this x is equal to 0, when this x is equal to -2, and this x is equal to 2. So this is all the information we need now to plot this graph. So let's just double check what they're asking in the first part. They want us to describe it, including the number of x-intercepts. We have that. There's 4 of them. The number of turning points. We have that. There's 3 of them. And the left and right behavior. What does that mean? That means as x goes to positive and negative infinity, what does y do? Now, that's pretty simple. Because x here is to the 4th power, it doesn't matter if we take a negative number or a positive number, it'll always go to positive infinity, right? So, knowing all that, let's now draw the graph. So, what do we know? We know that there's 4 roots, right? Let's start with inflection points. We know that the inflection points are at 0, obviously, at -2, and at +2. If we plug in 0, then y is equal to 3. So the graph should go through about right here. And we know that there's 4 roots. And they're just here, 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 and here. So the graph should look something like this, if I can draw this freehand. It'll start with positive infinity, then it'll go down through this root, come up here, inflect here, go back to this root, inflect, and go back up. So it'll be like a rough W shape. Now, it came out really weird because I'm drawing it slowly, but you get the general idea. It'll go through the first root right here. It'll inflect, and the tangent will be flat at this point. The tangent will be flat at this point. It'll go through these 2 roots here. The tangent will also be flat at +2, and then go through another root here. And then shoot off to infinity as x grows, and as to the positive side and to the negative side. So, we have the graph based on what we have here. The 3 inflection points, 0, -2, and 2. So 0, -2, and 2. And we have the 4 roots that we found, right? These 4 roots can be seen here, the 4 blue circles. Now, here's the trick that I wanted to show you guys that we cheated to get the decimal solutions right here. So how can we do this by hand? So I'll show you guys how to do it right here. We have the biggest root, obviously, it's square root of 4 plus the square root of 13. So how can we do this? Obviously, I hope it's obvious that the square root of 13 is between 3 and 4. Why is that? Because 3 squared is 9 and 4 squared is 16. And obviously 13 is between 9 and 16. So to approximate the square root of 13 by hand, the first thing we do is we take 13 divided by 3. We get 4.33. And we take the average of 3 plus 4.33 divided by 2. And the average is 3.67. Now we repeat the process. We take 13 divided by 3.67, and that is 3.54. And we take the average, 3.67 plus 3.54, and that is 3.61. And we repeat it one more time. So 13 divided by 3.61 is 3.6. And of course, the average of 3.6 and 3.61 will be 3.605. Now, if we plug this into a calculator, you'll really see that the 3.65 is the square root of 13. Now, to get the full solution, we have to still take the square root of 4 plus 3.605, or the square root of 7.605. But since we already cheated, we know that it's 2.76. But this is the neat trick that you guys should really understand, because taking square roots by hand is how they used to do it back in the day. But now we're lucky enough to have calculators in our pockets, so we don't really have to worry about it. So that's it. I hope you guys like this video. Please click subscribe and stay geekly, my friends.